Hi, I'm taking Paul McWhorter's vPython tutorials. We're on number 18, and the homework for today was to make our clock better. So that was an interesting, wide open thing to do. And there's been a couple of nice videos posted of what others have done already. So I figured I'd get busy making mine. So I decided to go a little bit different direction on mine. I figure if one clock's good, that multiple clocks is better. So I've been playing around with the classes and putting them into modules and separate module files so that we can use them in other programs as well. So I figured I'd do the same thing for a clock, for our clock project that we're working on. So we'll get to the code of doing that right now. So basically this is my file. This is our module, make clock, and our class is called clock. So we have to import our other external libraries that we need to use, and so we did that. This is just a function that I use internally with this to set an angle. So basically this lets us make a clock with whatever size we want to make it based on the clock radius, the face radius, and the clock position. We can put it on the screen where it is. And so far I've only been able to change the Y angle on it, so rotating around the Y axis. So I've ran into other problems trying to rotate it in more than one direction or other directions. So I'm just going to be satisfied with that for this example. So like I said, you have to put your self dots in front of these. So I got the Y angle, the position, and the clock size, bringing them in, and then anything that we used outside of this, we had to put a self in front of. If it's just used internally, you don't need to worry about that. You can see we've got that done a little bit there. So this is basically our parameters, like Paul's been showing us how to do. And one thing different down here is I have 3 empty lists that I'm using. So to rotate the clock, I found that it was almost impossible with all the minute marks and hour marks, and then I put numbers on my clock as well, that it was hard to get them individually rotated in angles. So I ended up making them into lists, and then I made compounds of each one of them, the minute marks, and then the hour marks, and then the text numbers I put into list. And then I compounded the whole face together so that everything except for the hands and the center shaft, I didn't put those into a compound. Once a compound's put together, you can't access it individually anymore. So that makes it kind of hard you can't get even positions off of a compound real easy. It changes it goes to the center of the whole thing, and it's hard to get the positions off of it. So, and basically that's what we did. And then we're making the center shaft, and then so this is where we start to rotate things here. I'm not going to explain that a whole lot. I found a site online where I found a little method to do that. So I put that at the top. That's up here, where you're just actually putting in a vector and then you're a vector and an angle, and it's spitting out the new vector that it has the new angle on it. So that's what I did there. So this is just showing how we use trying to keep those hands in the right position on a tilted face is a little hard. So I'm not going to explain it. I just had to learn this is all new learning for me, but learning about magnitude of vectors and hat vector, which is just a vector with a magnitude of 1. So that's a normalized vector, they call it. So learned how I had to do that before I could do this mag thing. And then you're using the position of something, the shaft position, the starting of the shaft cylinder is a starting position, and then you can add that V2 vector to it, and that gives you the new position of your clock and everything. So gives you a way of working off of knowns to get to what you don't know with a new, because your hands are going to be spinning in 3 dimensions, not just a 2 like we had them on our clock that was just in the XY plane. So had to do that. And basically that's just getting, setting up your position of your arrows, and then, you set the axis of the arrows when you run your program. So basically, and this was everything that was in the while true, or the part that affects the hands in the while true. For each clock, you're going to do that setting of the hands, and it's the only thing we're bringing in is time and seconds. So we're going to bring that into it and set our hands. And again, we're coming out using that function up there though to twist it, twist the vector in that way up there. So basically that's all we had to do there. So that's our new class and module that we have, and then the program to use it. We basically the rest of what we would have if we had it all together. So we're importing vPython, date time we need, and then we're going to have to import our new module. So we got a module, and then we got and I just called it MC module. And then, like I said, I got the scene set, and then I changed the background a little bit and have something going on for a little interest there. And then basically we're just making different clocks and stuff like that. So we'll get to how that works. But this is setting up for four different clocks here, and then we also set up for 2 clocks down here. So I got 6 clocks total going on. We'll see them, and then we'll probably come back and maybe talk about what we're doing here a little bit. But in the while true, basically all we do is each time through the while true, we get our time in seconds, the way I did it, from time in seconds since midnight. And yeah, I use that to set in my setting the clock functions. And all you have to do is you just pass the time in seconds to each one of your clocks, and it updates the minute, the 3 hands on the clock, all, for each clock. So that's kind of cool. Like I said, when you're doing the clocks, the biggest thing is that the numbers on the clock take a long time to draw, so it kind of slows down the beginning of your program. So you'll see how long it takes to get everything loaded onto the thing. But then by just putting these little, setting the hands of the clocks, that happens fairly good time. So we still, even with 6 o'clocks, we got pretty smooth time going on there. It's not jerky. It doesn't seem to be jerky at all. So, and basically, one thing I do want to point out is that, where is it? Okay, we got a color vector up here. And you'll see it's kind of really weird numbers. I wanted for one of the things I was doing, I wanted wanted a unique color, and I kept trying a couple colors and stuff, and it just I kept trying, but it didn't work out the way I wanted. So I think it was on the documentation of the screen. Of vPython, they tell you that they point to the link to this program, and basically you got, we're familiar with the RGB and the HSV from our AI classes, that you can actually just change them, and it's kind of cool because you can get colors like you want. I wanted something that looks sort of like copper or brass or something, and I was having a heck of a time. So this is kind of a fun way, easy way to do it with a couple slider bars. And when you get the color you want, we wanted it in RGB, so you just go ahead and, you can copy those numbers and just put them right in our program. I'll try to link to this GlowScript program. It's free for anybody to, it's online, so you can just run the program when you get in there, and I think it's already, it'll be running when you start up. But that's a nice way to, if you say, well, I want to make something a certain color, that's a pretty good way of doing it. So anyhow, so we'll get back to our programming. I did want to show that. And so basically, I'll come back and explain a little bit more about what we did with this part of the program, but I think the best thing to do is just go ahead and run it. So, and again, it'll take a little while to load. Putting some faces on some clocks. Like I said, I got a total of 6 clock faces on here. So I decided to do like mostly you see these in Europe, pictures of them in New York, like a plaza clock or something like that. And I got another clock over here that's a 2-sided clock that something you might see in a smaller town or something like that. But basically, it's kind of cool. You just got 4 clocks, and like I say, it's 1:29 here, so they're all keeping time and moving fairly smoothly, and there's all 4 of them all the way around it. So, and these all 4 are one size, and then I said, well, I need to make another one just to demonstrate that you can do it in different sizes. So I got this 2-sided clock here in the smaller size. And they're all keeping pretty much the exact same time and all moving kind of smoothly, and kind of cool that you're able to use multiple clocks. I don't know when you'd ever want to do that, but it was just an exercise to use my class and modules that I did. So we'll go back to the program. So anyhow, so you saw what they look like, so maybe it'll make more sense of what we did here. So basically, like I said, that color that I have here is the color that I got off that program, trying to make it a metal colored clock. Then you got the box for the main box of the clock. And then I have a pyramid for the top, and then a little ball on the top, just for a little decoration. The post on this one, I hadn't used the 2-dimensional gear or many of the 2-dimensional objects at all. So I said, oh, a gear would look like a, like a notched post going up. So I made a gear, and then you do an extrusion to make it a shape. So that's what the extrusion did. So I didn't really show that on the pole, but it's actually a notched pole for that one. And then basically you create 4 clock objects, 1, 2, 3, and 4, and you're giving them a size, a vector of where they are in space, their X, Y, Z, their position in space. And then this number is your rotation angle. So as you can see, you got 6 and -6, and then you get 6 and -6 in the other directions. So they're all rotating in the Y. Like I said, I couldn't figure out how to do the other 2 directions yet. I might work on it later, but basically good. And then the little 2-sided clock, I did basically the same thing. I used an arrow for the post on that one. So that's what the post is made out of on that one. And then clock 5, I've created a clock 3-inch, 3 radius clock, put it in a position, and this one is pi divided by 4. So if you notice, it was like 45 degrees from the shaft. And this one, I had to, these 2 things here, connect them together so that they're back to back. It's just referencing one off the other. So clock 6 uses that as a reference. And then of course for direction, it's pi plus pi divided by 4, so that it's 180 degrees from the other one. And then I used that same process that we used up here to get a axis variable to make our cylinder for that, for the in between, the green in between part of that clock. So basically that's it. That's all you have to do. And you could, I don't know how many clocks you could do, but I probably up to 10 would still run pretty smooth, I would think. 6 didn't seem to hurt it at all, even on this is on that slow mini computer, so it's still running pretty good. So we might go back and look at the clocks again. So yeah, that's that green thing that we saw, and maybe we can get close in on that post. You can already see that it has like a fluted shape to it, and that's that gear shape that we're using. I don't know whether you're going to get much better on that or not. Yeah, you're probably not going to see much more on that. Probably because I'm on the dark side of the clock. Oh well. Still getting used to making these move around in space. It's kind of hard to figure out. Whoa, went underneath of it. Okay, well, that's my homework for this week, and hope to see a few others post theirs. Paul, I want to thank you for all you do, and looking forward to tying this into the Arduino eventually. Thanks.